Hello, today we will be doing an experiment for Fresnel's equations for reflection. So the aim of the experiment is to verify Fresnel's equations for reflection of electromagnetic waves.
So I will be telling about the apparatus which is required for this experiment. First of all, we need a sodium source, then we need a spectrometer, then one prism and two analyzer we need. One analyzer is for this collimator and one analyzer is for the telescope.
Okay, let's see the theory. In case of the electromagnetic waves crossing a boundary, the Fresnel's equations are, there will be two equations. First we are using when the electric field is perpendicular to the plane of incidence, there we are using this formula. And for other case, when the electric field is parallel to the plane of incidence, we are using the second formula, which is R parallel.
Now I will be telling about the procedure of this experiment. First, before starting the experiment, we have to adjust the spectrometer such that one side is 180 degree and another side is 0 degree. And next process is we have to keep this prism in the center of this table such that two reflecting rays pass through this and we are going to observe a slit. After that, we have to measure, we have to see where the light is falling. And this is the step 1 and we will be finding A. A is nothing but angle of incidence. Now we have to take the prism out and we have to keep in such a way that the light only focuses on one side of the prism. This will give the refraction. The minimum deviation position is given by taking two sides of the angles. Then we have a formula. It shows the refractive index is given by sine. A is the angle of the prism and D is the minimum deviation divided by 2 and sine A divided by 2. This is the first two steps of the experiment. Now we have to take this analyzer and fix to the telescope. After that, after fixing to the telescope, the analyzer angle should be 0. After 0, anyhow we'll be observing a slit here. We should change the angle such that where the light is diminishing, that is the angles, Brewster's angles. After finding Brewster's angles from this telescope, we have to keep another analyzer to the collimator tube. Another angle to the collimator tube. Now this should be in 0 and we have to change the analyzer angle in the telescope. After changing, we'll be finding the angle of the collimator. So after finding that, we'll be able to know the position of the collimator where the polarization occurs.
So the result of the experiment is as shown below.